Thank you. Can you hear me? Hello. Everyone can hear me, right?
Yeah.
Thanks for coming. So today I will be talking about architecting IoT systems with machine learning. During the course of the talk, I'll just go through the journeys that I have done without introducing myself right in the beginning. So let me play a video, a quick video for you guys to wake up. So this is a video from Intel on smart homes. My question, how many of you live in such kind of a home? No one. How many want to live in this home or don't want to live in that kind of home? Everyone wants to live in that kind of a home with having smart home? Okay, I don't want to live in that home actually. Neither do you. But the point that I want to show is that video was, I think, a few years ago. But I remember even in 2008, 9, and 10, people were talking about this kind of a home where everything will be connected. Everything you will have the data. You will have all those information. But even 7, 8 years later, nothing happened. And even if you look at this graph, which is by Gartner, which in 2015, it's still in the hype, where they speak of inflated expectations. That's IoT in the state even now. So today, what I want to talk actually about, which I think I know quite a lot about, is how do you build IoT products for consumer adoption? So not just a technical solution, but a product. And I will go through the stories of my past 15 years, actually, of building different companies, products. And then I will give you some examples of things that maybe you guys can go and solve and build your own company. That's good? Cool? So my affair with IoT started 15 years ago, when there was no IoT. So let me just start where I first started. That was 2003 Bremen. The video is from Japan in YouTube, but this was the project I was working in, 2003. So soccer playing robots. So this was about how autonomous robots could coordinate, plan, and execute. And now, 15 years later, I'm working on a startup which is trying to make solar adoption everywhere by using satellite images. I'll tell you the story a bit later, but that's my experience. I will bring all of those experiences together and try to tell the story. But if I look at those last 15 years of IoT, we can see that IoT has stayed in this graph. How many of you guys have seen this graph? Okay, not many. So this is basically an adoption graph, which is any technology when it comes, it starts with an hype. Everyone is talking about that hype. It's called a hype cycle. And there are some people who adopt it. And then there is a called chasm, which is basically where majority beyond live. Most tech people do not live in the majority part. Most tech people live in the hype phase. So we end up building products, and then no one adopts. No one, majority doesn't adopt it. And we stay in the initial hype phase. And basically, my background is also, I'm a developer, I build systems. So I also belong to that hype phase. And then moved on to build startups. So I would know, or I have done things where I moved from the hype phase to the majority and built products for most people to adopt. So that's the journey that I want to talk to you about, that how can machine learning help to build systems, specifically in IoT, which can help to cross the bridge. Now, when we look at IoT over the last 15 years, or even earlier on, I mean, IoT is not 15 years, it's even before that, we'll realize what went wrong. Why was it not adopted? Basically, when you classify any IoT system, you can put them into, most of the functioning is basically this graph. Somewhere you are generating data, you're storing the data, and then you're viewing the data. And you can classify almost all IoT systems in this group, either in smart home, or transportation, or any sector. Now, think about it a bit. You're storing a lot of data, big data, fine, and then you can go and view the data. Does that really has a value for you? Or for anyone? Why? It has no value for me because I already know what I did. I mean, it's nice to see, but it doesn't really make me use it more. And most IoT startups and most IoT things end up just collecting the big data. The whole idea of notion of big data, okay, we are getting a lot of data, we are doing some analysis, we are reviewing the data. But that's where it all ends. And there were actually very few killer applications. Very few, almost none. I mean, very few applications that actually change people's life, that solves people's problem. Even if you look at smart home case, the video that I showed, really, you guys said you want to live in such a home, but I don't want to live in a home. Why do I care about what I did yesterday, which will show me some smart numbers, or some numbers? Doesn't make sense to me. Beside that, so this is one major problem of IoT adoption, that it didn't work because there was not solving a problem. But there's also something called hidden cost of IoT. So most data in this world are relational in nature. I guess most of you understand relational data, right? So all companies, most data is relational. But the IoT generates something called time series data, which is often big data. Now, if you have to bring these two data together, because my legacy data all is in relational form. Now I'm generating through IoT device a lot of time series data. So the architecture ends up being something like this, where you have to do, on one side you have a database, which is doing the standard SQL query. And then you have another side, you have the big data, well, the Mongo or Cassandra kind of database. And you're doing a time series query. And then you have to merge these two data. Now that's expensive, because you have to write a piece of code that is merging these two data. And then you are doing a user query on that application layer. So that's a cost that a lot of startups, when they started building or using IoT, didn't think about. Because building a use case a simple use case or a prototype is very easy. You bring a data, you store the data, fine, you view the data. But when you go to sell to companies, or you're telling that, okay, this will be used in real world applications, you have to integrate with the existing systems, which are often using relational data. So that's one of the hidden costs of IoT. Luckily, last year, actually, I was working for a startup. They were trying to solve this problem. They raised $16 million a few months ago. It's an open source database, and they raised $16 million. The way they did that was it was basically a SQL time series database. So what they did was they basically made a database which is SQL and time series combining into one database. So you don't have to build another time series data. Does that make sense to most of you? Cool. So they were solving this problem, and that's why they were able to raise it. But before 2017, no one was solving this problem. So a lot of IoT adoption failed also because they couldn't combine with the real world data. And the second problem was, of course, the data volume and the speed. That there was an issue of a lot of data that is being stored. And this is a typical architecture that you have to follow, where you're storing, in my case, I'm using Amazon S3. It doesn't have to be Amazon S3. It could be any kind of storage, which is an S3 is storage. And then you have an instance and you're storing it in DynamoDB, which is a database, big data database. So this was also an expensive thing. So there is the problem of, I'm trying to argue that the problem of IoT adoption didn't work because, one, user not solving a problem. Secondly, there was a hidden cost attached to IoT. And it's not creating enough value for anyone to go and adopt it. So if you are thinking of building a product, and I always think building a product is not just about writing a piece of code. It's about adoption. If you're thinking of building a product, you have to think of those issues. Now imagine if I tell you that I want to build systems where I want to not build for the hype, but for the majority. And there is only one way to do that, which is you have to solve a real problem. I'm also a mentor of Google Launchpad, so I always say that there is one saying called build painkillers, not vitamins. So you have to build things that really solves the problems. And today I will try to argue through different examples that how could you use machine learning that actually builds solutions to solve, build painkillers rather than vitamins. So I will tell the story through my startup. So all the things that I'm saying here is through my experiences. So I had a startup in Belgium. What it was doing, it was recording driving data. And we gamified the whole system. So how we did that is you drive, you collect points, and once you get points, you get some rewards. So there is an incentive for you to drive better. Now, it is an IoT in a way that your mobile phone acts as your IoT device. What we saw that just by simple gamification, forget about anything else, simple gamification, we were able to collect over 4 million driving kilometers within a month or two. And we also saw that the behavior of drivers is improving. They end up being better drivers. So a simple thing, if you're building an IoT system, a simple thing you can do is just simple gamification, gamify the system. Gamifying is create an incentive so that people can use the system and give them a reward. So when we come to the IoT architecture, this basically comes down to something like this. So instead of just having a viewing, you add a layer of gamification where you are giving people to incentivize, to a nudging, and you're not forcing, and so that people are engaged in what you are doing. So that's the first layer of building a product which you can make people use or adopt. But do you really think that majority will still use this kind of a system? Most likely no. The reason is that there is no clear value. I mean, you can give me some free rewards, but there is no clear value for me still to use it. So I wrote an article about it. I always say that, stop identifying cats and start creating value. So one of the things that I speak about and I write about machine learning is this is great to do things like recognizing cats and dogs in a picture, but that doesn't really create any value. So the key is that if you want to build something, how could we build something that is creating value? So let's see if machine learning can come and do that. So in a short line, if I have to say what is machine learning, it's basically learning patterns from your past data. That's basically it. Most AI, I've been in AI since like 15, 16 years. Now AI, if you look at the development of AI, it started, there was a planning, graphs, genetic algorithm, a lot of different kinds of algorithms. So now a lot of focus is in machine learning. Now machine learning, and I was talking to someone who said machine learning and AI is very complicated. It's actually no. If you really want to understand at a very intuitive level, it ends up being just understanding certain patterns of data. And there are algorithms, I will go through some of them, to show you how they learn those patterns. But it's just pattern learning. Do you call that intelligence? I don't, but Okay, let's say if that's form of intelligence, that it's just able to learn certain patterns. Now, why is that useful? Now, why people are so much talking about AI and machine learning? The reason is that there is a pattern in everything that we do. So, if a machine can recognize the patterns, then it can predict the future. Now, what prediction is? Basically, if I know I behave like in certain way in the last 5 years and the last 5 days, I would behave like the same in the 6th day. And that's the power of machine learning. What humans cannot do. Now, there is a book called Thinking Fast, Thinking Slow. I don't know how many of you read it. It talks about human cognitive thinking, and we are biases. Now, we are not able to do those analyses very well because our mind is not suited to analyze data. So if machines can basically analyze those data and find those patterns, that would be quite helpful for us. So let's go back to the problem that I was talking about the driving data. So this is our data structure that we ended up with. So we had a lot of data, which was about driving data, risks, how they were driving, speeding data, where they were driving, a lot of that data. What we did is basically imagine if we could use the data and add a machine learning engine on top of that. Now, I'll go through what are those engines, and then provide certain analytics that is basically for the future. Now, that could be very useful. Now, let's say I want to tackle 2 problems through that. Now, what kind of algorithms can I use? Where can this analysis can come in? Imagine that if I could analyze who are the risky drivers. Now, this is something, even the simple thing we don't have. Insurance companies don't have that. So imagine if we could just analyze who are the risky drivers. That would mean majority of us will end up paying less because there are only 1% risky drivers for whom we are basically end up paying more. And that is a value for all of us. So what happens that there is 1% who are bad drivers who cause accidents for whom the rest 99% pay high. Now, if I could identify those 1% and increase their premium, then the rest of us end up paying less. That's a clear value for almost everyone. And who doesn't want to use that? Who doesn't want to pay less? So that's a clear first value. And the second value is imagine if through machine learning, I can predict future, short and long-term future, which would end up making roads safer. As I saw, even for a simple gamification, simple reward system, people end up driving better. So if we could do that, that has a huge value, which everyone would like it. So if we could build such a system, everyone would use it, solving a real pain point and creating value for everyone. So for the sake of this talk, I will make it in machine learning into neural network because machine learning has a lot of different algorithms, k-means and things, but I'll just restrict to neural networks. I can argue the reason later on, but not now. So let's start with a very simple case. Can we find patterns of a risky driver? So there's something called clustering. There are standard algorithms of clustering. K-means is one of them. As simple as it groups people into buckets, right? So in neural networks, there's something called self-organizing maps. I will explain that briefly. Again, you don't need to know all of these algorithms. There are libraries. You can easily go and use those. But I try to explain you how it works in a way to understand for you guys to see, okay, this is how the clustering would work. So self-organizing maps is basically unsupervised learning, which means that our data is not labeled. So we don't know initially who is a good driver and who is a bad driver. So we don't have anything to train on. Most machine learning systems are supervised learning, which means we already know who is good and bad, and we can train the machine. Here, we cannot. But what we do is we start with already assigning random weights. So our goal is to take this 3D space, which is the input, the 3 green colors are input, and map it into this 2D space, which is in the box. There is a weight assigned from each input node to each of the output nodes. Let's say the input is 0.15, 0.31, 0.49. I will give you through an example so that you can understand this case. And what we do, we calculate a Euclidean distance, which is, the value is there. It's basically a square root of the mean square of the distance, which is a difference between the weights. So we calculate that for every node in the output. Okay? And then we select the best matching, which is the lowest, the one which has the lowest distance. So in this case, I picked 2 nodes. I put the assigned weights. And in this case, this one will be, let's say, the one with the lowest weight. Is that simple, right? And then what you just do, you adjust the weights of the nodes around them to be similar to this selected node. So let's say we pick the tree around, and we adjust the weights similar to the first one. Now, why does that work? Now, what it would do that in future, if you have a similar input, it will also trigger one of those outputs in the yellow. So your input, most of the input will go around that region. And you can repeat this process, so it will end up creating groups which are similar. So it's a very simple, unsupervised learning, or one of the most used unsupervised learning machine. Now, is that simple, right? It's not like rocket science. It's just simple understanding of mathematics. So what we'll end up having is grouping of those drivers based on their scores. So what was the input? Here I explained to you the inputs are the scores that they got. So what are the scores? They have score of braking, overspeeding. They had the score of mobile usage and acceleration. So 4 scores, then we are mapping them into a 2D space. And then we'll end up having groups. So then we can just find out what are these groups about. So we can group risky drivers in one group. Once we know who are these risky drivers, we can then identify them, and we can give them premiums which are higher, let's say. And I'm not just theoretically saying that we were actually working with insurance companies in France and Belgium on this, including one of the biggest insurance company in Belgium. So that's a clear value. So this is one of the simple machine learning algorithm which will help us to group drivers into identify certain patterns and group them into risk or no risk zone. And then we can add value by creating them, a premium value, which is depending on how well they are driving. So next question is, can we go further and try to predict the future using machine learning? Now, as I said, machine learning is simple as analyzing certain data, find those patterns, and realizing that those patterns will be repeated. So there is an algorithm called word-to-vec, which is basically the idea of it's a simple neural network. It's a semi-supervised learning. So I will not go in details of that, but it's a semi-supervised machine learning neural network with one hidden layer, which is one of the simplest form of neural network. No deep learning. What it does, one of the form of it is given some input words, is predicting the next word in the sentence. Now think how, again, it might sound for some of you, it looks like rocket science, but that's not really, because there is a pattern in everything. So if you're saying, how are you, most of us would know the next question would be today. Like that's most likely we'll be asking. How are you? If someone says, tell me the next word, most of us say today. Because we know those patterns, we know those repeat patterns. That's what this machine is being trained also. So the machine is being trained with a lot of sentences, and it just learns what are those patterns. So given some input, new words, it will know what is the next word to be expected. Now, why am I saying this? How is that relates to driving cars, or what is the relation? The thing is, another thing is that word2vec has ended up creating some very interesting features. One of the things is called word embeddings, and I will explain you this a bit. I will not go into too much mathematical, but the word embeddings is basically for every word, the input, the X you see is a vocabulary. So all the words, there are XV number of words. For a word, the word embedding is a dot product of the weights. I will give you through an example I will explain you. Let's say the word is, there's 4 words, there's only one. And then you do the weights in matrix, and you end up having a matrix as a dot product. So that's a word embedding of that input word, where your input words are from X1 to XV. Only one of them is triggered, let's say. Now, what you can do is you can translate this matrix, which is n-dimensional, in this case, I think 4-dimensional, but could be n-dimensional, using something called PCA, principal component analysis. Again, we don't need to know that. The key is that you can translate that into a 2D space. And once you translate it into 2D space, you see that similar words form in the same groups, like what SOM was doing. Now, this is a feature, even the people who build Word2Vec didn't know that. They didn't thought about it. But it makes sense. It makes sense because similar words occur in similar situations. So once you plot that in a 2D space, they all are grouped like that. That's one feature, which is very interesting. The second feature that ended up even more interesting was not only that they were in similar groups, they also had the vector distance. They were maintaining the vector distance. So a simple thing like Germany minus France plus Paris would give you a Berlin in the 2D space. Now, why that is, again, it's happening because it was training the machine that in sentences, typically Germany, Berlin, appear in the same context as France and Paris. Now, that's a very interesting feature. Now, so basically this neural network, if you train it, it stores the semantic relations between the different inputs and outputs. The semantic relations are not just distance, but the semantic relations. I think semantics is where the meaning of those words appear. So imagine if we want to predict the future, we will train the same network where our input is, let's say, the score on a Friday or a Saturday, and then I can know what is the score on Sunday, because there is a repeat pattern of those behaviors. And this is very interesting, because if we know that this person drives like this on a Saturday and Friday, we will be also know that this person most likely will be drive like this on Sunday, because we know his past patterns. Now, this works in a short-term duration. The reason is you cannot, this works on you cannot predict like this on 3 months before, but you can do that on a very short duration time, because the behavior doesn't rapidly change in a very short, within few days. So imagine if we could do that. So we can even give a warning to people. So they drove certain way, and we know that this is how he will going to drive. So we can give advanced warnings. So that's the power of machine learning through this system. The next level is, can we even use machine learning to predict long-term futures? So there is a class of algorithms, machine learning algorithms called RNN, which is recurrent neural networks, which is a series of neural networks. It's not just one neural network, it's a series of neural networks. And the series is basically a time over a lot of different time. I will again explain this algorithm briefly, that how does it work. And I'm trying to explain this because I think it's very important for people to understand the algorithms work rather than just coding it to use these libraries, because you can use the libraries because that doesn't really help you to understand the code or how they work. So in LSTM, this concept of memory. So in your previous neural networks, there was no concept of memory. But in LSTM, there's a concept of memory. And what does a memory does is it passes over from the time. So this is called cell state. And this is passing over from different cells. And this is what would be stored, that once someone is doing some action, then it passes to the next cell and to the next cell. So that acts as a whole memory. And for each cell, there are 3 parameters, which is basically a forget, an update, an input get, and output get. What basically does is, from the previous memory, there are multiple neural networks. Each of those NN is one cell, is not one network. It's like a combination of 4 neural networks. And one network is forgetting something from the memory, one cell is updating something, and one cell is outputting something. So over time, it stores how a person's behavior is, and it remembers the memory, which previous neural networks were not able to do that. So if you could use LSTM, we can potentially use LSTMs to input scores at different times. Because our behavior not only depends on the short term on a Friday, Saturday, Sunday, but it could be in October how we would behave, and December will behave in a different way, and in March we'll behave different way. Because there's a weather factor and there are other factors also. So that's why we need a long-term memory. So LSTM we could use to store this long-term memory of people's drivers. And that could use to even predict a long-term future. And long-term future is very important because then we can use that to change behaviors. Much bigger than a short-term future, we could do that. So, and there's a concept called nudging, which is incentivizing in certain ways. And then we can change people's behavior through making roads safer and making the people be a better driver. Because that doesn't happen on a weekend level, that happens at a month level or a few months level. So to summarize, I showed you a case where we build through simple 3 machine learning algorithms. These all 3 are actually quite simple algorithms. Where, first of all, you can make the road safer. You can improve the premium, so there's a clear value. And you can incentivize to be a good driver. And that's a clear value for people to adopt and use. And at the end, as I said to you, who will benefit from such a system? Most of us will benefit from it. So I would like to give you some more examples of what other kind of applications that we can build. So this is a project I was working in when I was in Cambridge. It was in Prague, it was smart meters. Now, I started with a video on smart metering on the home mid, but it was never adopted. The reason was because there was no value for that, people to adopt it. But if by using machine learning, we can predict people's behavior through the architectures that I said and through those 3 simple algorithms, people would know what they're going to consume tomorrow. They can save money. And then if they know when they can save money, they will save electricity. So that's a clear value. And who will benefit? And this is a picture I shared. And this is not about just the rich people, because rich people don't care about saving money. It's the poorest of the people who have been left behind. They can get that monthly bill, and they can be told, like, look, this is how you can improve the system. Or you can improve your energy consumption, which will end up making you and saving money and also saving